This lesson is inside angles and tangents, and our learning target is I can solve problems using inscribed angles and tangents. Okay, so first thing we're going to talk about is some definitions. So, an inscribed angle is an angle with its vertex on the circle with two sides that are chords. So, if you look at angle ABC, notice the vertex is on the outside of the circle, and then you have two chords making up the sides of the angle. Okay, so the next thing is we're going to talk about an intercepted arc. So an intercepted arc is an arc that lies between the endpoints of the inscribed angle. So this would be the intercepted arc. And then the last thing, the measure of the inscribed angle is equal to half the measure of its intercepted arc. So here's what I mean. This angle ABC is equal to 1/2 of the measure of arc AC. So that's what you need to know in order to solve the problems for today. So if we intercept a diameter, if an inscribed angle intercepts a diameter, then it is a right angle. Alright, so here is an angle ABC. It is an inscribed angle. And here is the arc that it's intercepted. So that arc would be 180 degrees. And then half of 180 degrees is 90 degrees. So that's why the measure of BAC is 90 degrees. So that would be a right angle right there. All right. And then the last thing we're going to talk about is overlapping arcs. So, if two inscribed angles intercept the same arc, then the angles are congruent to each other. So if you'll notice, angle ABD and angle ACD are both having the same intercepted arc. So that means they both have to be equal to each other. So the measure of ABD is equal to the measure of ACD. If they're intercepting the same arc, they have to be congruent angles. All right, so let's look at this one. So I'm going to highlight the inscribed angle, and then here's the arc. Okay, so if the angle is 47, the arc is twice as much as that. So the arc would have to be, 94. Okay, but notice the problem is actually asking for the measure of BC, and BC is over here. But 94 and whatever BC is have to equal 180 degrees. So if I do 180 minus 94, I get 86. So that's how you would do something like that. All right, for the next one, I want to find the measure of PQR. So that is an inscribed angle. It is intercepting 180 degrees, a semicircle, and half of 180 is 90. So the measure of angle PQR is 90 degrees. Okay. So sometimes it's hard to know where to start because you're actually going to find things that you wouldn't necessarily think you need, but you do in the very end. So here's my inscribed angle. Here's my intercepted arc. If the angle is 67, the arc is twice as much as that. So it's going to be 134. Okay. And then you should realize that the entire circle equals 360. So this arc is 120. The orange is 134, which we just found. And then the other, 5x plus 21, they all three have to add to give us 360. So what I'm going to do is I'm going to get my like terms together, and you should know how to do that by now. If you're having trouble, please let me know. Okay, so my like terms, 5x plus 21 equals 106. I'm going to subtract 21 from both sides, And then I'm going to divide by 5 on both sides, so I get x is equal to 17. Okay. I want you to try the first one on the left. I want you to pause the video and try it. 1, 2, 3. Alright, so what you should see is that you have an inscribed angle, an intercepted arc that's actually a semicircle. So that angle has to be equal to 90 degrees. So then I add 1 to both sides. I'm going to divide by 13 and I get x is equal to 7. Okay, I'm going to do the next one with you. The measure of FGH is 6x plus 21. The measure of arc FJH is 17 minus 28. And we want to know what the actual another measure is. Okay. But what we know is that an inscribed angle is equal to half of the arc. Or we could say the arc, forgot the x, is equal to twice as much as the inscribed angle. I think it makes a little more sense in my head to do it like that, so that's what I'm going to do. So if I distribute the 2, I'm going to get 12x plus 24. I'm going to get my like terms together. I'm going to add 28 to both sides. And I'm going to divide by 5. X equals 14. Okay. But that's not what the question asked. The question actually wants me to find FJH. So now I'm going to plug it in right there. So 17 times 14, and then minus 28 is going to give me 210 degrees. And remember, because it had 3 letters, our answer should be above 180, and it is. That's a quick way to check your math. All right, so let's talk about some tangent lines. All right, a tangent line intersects a circle at exactly one point called the point of tangency. So this line right here, AB, is a tangent line because it's intersecting the circle only once at point A. Right, that's what you need to know about that. A line is tangent to a circle if and only if it is perpendicular, which remember that means it meets at a 90-degree angle, perpendicular to a radius drawn to the point of tangency. So that blue line is only perpendicular if the point of tangency is on the radius. So what happens is you make a right angle, and then you can start to do stuff like right triangles and use Pythagorean theorem, things like that. Okay, so we're going to determine if AB is tangent to circle P. In order for that to happen, this has to be a right angle. So that's that theorem we just talked about. In order for it to be a right angle, Pythagorean theorem has to be true. So here's what the theorem says. A leg squared plus another leg squared equals hypotenuse squared. Remember, hypotenuse has to be the biggest side. So we're just going to see if this is actually true. So 8 squared is 64, 15 squared is 225, 17 squared is 289. If I add these two together, I do in fact get 289. So yes, that line is tangent to the circle because it makes a right angle. Now we're going to do the same thing with this one over here. Let's see, 14 is a leg squared plus another leg squared, 11 equals. So notice the hypotenuse is not 5. 5 is only from here to here. But anywhere you draw a radius, it's the same amount. So this is actually 11. So the hypotenuse is 5 plus 11, which is 16. So we're trying to determine if this exists for the Pythagorean theorem. So 14 squared is 196. 11 squared is 121. 16 squared is 256. When I add these two numbers together, I get 317, which is not equal to 256. So this one is a no, it is not tangent because the Pythagorean theorem doesn't work. All right. Now, we're going to still use Pythagorean theorem, but we're going to say, we're going to try to find x. So we're going to set it up the same way. Be careful on these because sometimes it's a little hard to see what's actually a radius and what isn't. So this is 11, so this side is also 11. So when I do Pythagorean theorem, this side is 22, so 22 squared plus the other side squared must equal the hypotenuse squared. Alright, and this just comes with practice, getting used to this. Alright, so 22 squared is 484. 25 squared is 625. I'm going to subtract 484 to the other side. And then to get rid of that square, I'm going to take the square root of both sides. So x equals about I can't read, sorry. X equals about 11.9. Okay, so go ahead and try the second one. See if you can do it. Pause the video and try it in 1, 2, 3. Okay, so for this one, sometimes people have a hard time setting this up correctly. Alright, so the two legs are the two that make the right angle. So leg squared plus other leg squared equals hypotenuse squared. So if you didn't set it up correctly right then, it's probably going to be wrong. But it's a quick fix, and it gets easier as you do this. Okay, so 7 squared is 49. 19 squared, 361. If I add these two together, I get 410. And then I'm going to take the square root of both sides. So x is about 20.2. So hopefully you got the same thing. If not, you can ask me questions. If you did, awesome. Let's move on. Alright, so here's just some more tangent line properties. So if two segments from the exact same external point to are tangent to a circle, so both of those, then they have to be congruent. Alright, so they intersect at the same point B, kind of like a duck bill. So those two have to be equal to each other. Alright, and then this might be a new word. And be careful when you say this one out loud, because some people say it and it's not what they meant to come out. If a polygon is circumscribed, which means it's on the outside of a circle, then all sides are tangent. So what that means is that these two are equal to each other, and these two are equal to each other. So the two that meet at the same point to make the duckbill are the two that are congruent to each other. So now we're going to use those to do some problems. So we're going to find each value or measure and assume the segments that appear to be tangent are in fact tangent. So the first one looks like a little duckbill. So they have to be equal to each other. So we're going to set them equal to each other. Alright, I'm going to get my like terms together. I'm going to add 19 to the other side. And I'm going to divide by 3. So I get x equals 14. Alright. Then the next one's a little bit trickier. I know that these two are equal. So I'm going to set those two equal to each other. And I'm going to figure out what x actually equals. So you should be good with this method by now. So x equals 8. Okay, the next thing I'm going to do is, because I have this side, I'm going to go ahead and replace x with 8 and figure out what that side is. So if I do 10 times 8 minus 41, I'm going to get 39. So here's what I have. I have this little triangle up here. This side is 17, this side is 39, and then I can use Pythagorean theorem to figure out what the other side is. So a side squared plus a side squared equals hypotenuse squared. So I can do this math really quickly. And I get 42.5. Okay. Alright, and then I'm going to do the first one, and then I'm going to let you try the second one. So these are the ones, there's like multiple duckbills going on. So these two are congruent to each other, these two are congruent, and then these are congruent. So if the D to H is 11, D to G is 11, then D to H is also 11. If H to E is 16, I to E is also 16. If F to I is 9.5, G to F is also 9.5. And the way you find perimeter is to add all the sides together. And when you add all the sides together, you get 73. So I want you to pause the video and I want you to try the second one and see if you can figure it out. Try that in 1, 2, 3. Alright, so how to use a little mathematical reasoning. But that should be what you get, and then when you add them all together, you get 180. Alright, so if that didn't make any sense, let me know, and go try your assignment. Bye.